Okay, so now that we have a fair degree of understanding what regression is, let's look at some of the various types of regression. The most common type of regression is linear regression. And I'm going to explain in extremely simple terms what linear regression is. And you might have already guessed that linear regression means something that is a straight line. So let's say that for the regression piece, we were having few data points, right? And these data points could be like this. There'd be one data point here, another here, another here, another here, another here maybe, right? And we have to do regression. Now assume that these data points are on an x and y axis, right? So I'm just drawing them like that, but let's say they're on an x and y axis. And then you wanted to find the line that is the regression line between these data points. The regression line in this case would be a straight line. And if the line is a straight line, I'm sorry for my drawing, it's probably not exactly straight, but if the line was a straight line and it kind of fit these points to the best possible extent, then this line would be a linear regression line. And that is what linear regression is. That is how simple linear regression is. Now, let's get on to the concept of nonlinear regression. Now, in extremely simple terms, any regression that is not linear is nonlinear regression, right? That's a very umbrella term. When we say nonlinear regression, it is a very, very umbrella term. And nonlinear regression has various other types of regressions within it in various other forms. And some of these forms is what we're going to cover right now in this module. So one of the nonlinear forms of regression is logistic regression. And let's take a look at what is logistic regression, right? So let's say we had our data points in a manner that we had data point 1, data point 2, 3, 4, 5, and we had these data points in this fashion, right? So they spread out, and this is where they are highly concentrated. So we have a lot of data points here. And then on the other side, we have additional data points which are highly concentrated on the top, right? So there are a lot of data points here, and then it slowly starts spacing out, right? So as we move closer to the x-axis, so the x-axis goes towards 0, the occurrence reduces. Now let's say these are the data points. This is again an x and y axis, right? The way to do a curve fitting for this type of data points would be the curve would actually start from here, and then it would go up somewhere like this, and then it would hit here, right? Now this type of a curve, this nature of curve is actually a log curve or a logistic regression curve, as we would call it. So if you have data points of this manner, then a logistic regression curve would actually fit your requirements. So this is an example of one of the nonlinear types of regressions, which is logistic regression. If you move on, we can look at polynomial regression, and polynomial regression is actually pretty easy to understand. So in cases of polynomial regression, you would have these particular data points, right? And these data points would not be on a straight line. You cannot fit a linear regression to it. It may not even fall into a log regression. So a polynomial regression would take a more complex mathematical formula, which would be a polynomial formula, and that formula will put your polynomial regression curve to something like this, right? And then this particular formula would be like y equals to a particular function of x, where this particular function is a complex polynomial function that gets the curve in this particular fashion. It will not be linear, it will not be log, it will be a complex function having one or two variables and constants and some variation between them and certain multiples and certain power of something, or something of that sort, and that would bring a polynomial regression. And this again is an example of a nonlinear regression. Now there are several other types of regressions also, but we're not going to cover them as part of this course, because if you look at it, then you could categorize these regressions into particular types, or you could just say that there are infinite types of regressions possible, right? So almost every curve that you have, you could have a particular name given to it. It could be a helix, it could be a lasso, it doesn't matter, right? It could be a parabola, and then there would be regressions for each of these types of curves. So it's a never-ending list if we start covering these, but we kind of covered the major ones and the most common ones, which is primarily linear regression, logistic regression, and polynomial regression, right? And the logistics and the polynomial and almost everything that is not the straight line, which is not the linear regression, will be treated as nonlinear regression. There are very few items in the world that would actually fall into a linear regression model, but a lot of the items that we do in practical life would fall into a polynomial model or a logistics model. So, but some of the other models like a parabolic curve or a lasso is kind of not that common. So you have to know what you're trying to do. You could have sine waves, you could have cosine waves, you can have tangential functions. There are a lot of other aspects. There could be circular functions, and there are a lot of other ways you can do regression over data, and it could take a lot of parameters and a lot of combinations, but that's kind of very, very specific to your requirement and specific to a use case. So logistics and polynomial are the most common forms of nonlinear regression. The other are less common, and they could be used based on the specific needs of your application. So it's important to know that there are more forms of regression available, but we don't have to study all of them because they may not really get used in practical life.